The formula that I got was C7H12O2, so I started off by calculating IHD, which is 2 times the number of carbons plus 2 minus the amount of hydrogens. There's no halogens or nitrogens having any additional effect, so we're just going to divide this by 2, which gives us an IHD of 2. We know that this means we either have a triple bond or 2 double bonds normally. There are other possibilities, but that's normally what we see from frequency NMR. So if we look here at around 1700, we have a peak of carbon double bonded to oxygen, because that's typically what's representative at a 1700 peak. Anything before 1500 is being disregarded. We see that there's no triple bond here, so we know we most likely have 2 double bonds. So over here, right before 3000, we see we have an sp3 carbon hydrogen bond, and then right after 3000, we have an sp2 carbon hydrogen bond. This lines up with our 2 double bonds, because this most likely means we have a carbon-carbon double bond. So now we're going to go ahead and take a look at proton NMR. So right here we have a very shielded group. It's not really moving downfield, and there's 2 peaks together. We know this is most likely an alkyl group. Over here we have a peak that's around 40 to 80. That's typically representative of a carbon bonded to something that's electronegative, deshielding it a bit, which we can assume it's an oxygen here. Here we see 2 peaks that are equal distance from each other and about the same height. That's typically representative of a double bond, and that's going to be our alkene double bond, that carbon-carbon double bond that we saw here. And then lastly, we know that our ketone is going to be the most deshielded. That's our carbon-oxygen double bond that we see, all the way to the left. So now observing proton NMR, at the first peak, we see we have an integration of 6H and a singlet. So that probably means that we have a carbon attached to 2 methyl groups, like an isopropyl group essentially. And there it's a singlet because there's no neighboring hydrogen. So we know that there's not going to be an implicit hydrogen here. So it's attached to 2 other groups, the central carbon. Over here, we see we have a peak at around 2 ppm, and it's 3H, meaning that it is a methyl group, and it's a singlet, so it has no neighboring hydrogens, and we know that it is has a slight chemical shift, which is representative of it being attached to a carbonyl group. Over here, we have a peak that has an integration of 2H, which is a doublet, so we know that it is a CH2 attached to something that has 1 neighboring hydrogen, which I have my final structure here, and if we look at that, that's going to be this bond we have right here, this CH2 attached to this implicit hydrogen here, which is why we see that doublet. And then over here we have a 1H integration, so it's a single hydrogen. We know that this is probably going to be this hydrogen right over here, because it has 2 neighboring hydrogens, which are these right here, and there's nothing else on those other sides, and that's the only peak left that it could be. So now this is going to be our final structure, and we can double check that this is all right, because according to our formula we have 2 oxygens as we see here. The peaks on carbon NMR line up with the amount of peaks here. Same with the peaks in hydrogen NMR. We see we have 4, so we have 1, 2, 3, 4. So everything matches up, and this is how we know this is going to be our final structure for the graphs given.